Live on WFLA Now. With a specialized degree in climate, Chief Meteorologist and Climate Specialist Jeff Baradelli is pioneering the way we look at climate and extreme weather. Welcome to Jeff's Climate Classroom, powered by ArmorView Window and Door.
Hey everybody, welcome to today's Climate Classroom. The Atlantic is en fuego. Right, Val?
Yeah, that's right.
It is really hot. And I do mean that. I mean, not literally, obviously. But it is very, very warm. Uncharted territory. By far the warmest it's ever been during the month of February in the Atlantic Ocean. And typically a warm Atlantic Ocean, especially in the main development hurricane region, during February correlates to an active hurricane season. So, of course, we're hoping that's not going to be the case. We're going to be talking all about that. I'm going to show you some graphics. You're not going to believe how out of bounds the water temperatures in the Atlantic are. If you've been following along, they were astonishingly warm last summer relative to what they should be. And actually, they're even warmer now relative to what they should be. So joining me today is our very own Val Simpson.
Hi, everybody.
She is a part of our weather team. You've probably seen her on this program. And she is also climate curious. What does that mean, being climate curious?
That means that I have a lot of questions for Jeff. And if he's going to speak with answers that are going to go way above my head, I am going to buzz him with my trusty buzzer like this. I'm going to say, no, Jeff, take it down a notch. Right. We need to understand this a little bit better.
Going on a tangent, you're going to reel me.
I'm going to reel you in, yes.
Okay,
but also, I am going to be keeping a look at our Facebook. So if you're watching us from our Facebook page, if you have any questions you want me to ask Jeff, I'll be looking at these and I'll be letting Jeff know that we have some questions that he needs to answer. Okay?
We are going to be talking about what the implications may be for hurricane season. Of course, it's very important to us.
Yeah.
You remember last year, water temperatures were very, very warm in the Atlantic, but we had El Nino, which was combative to hurricanes in the Atlantic. We ended up still with 20 named storms. The average is 12 to 14. So somehow the warm water was able to overpower El Nino. Yeah. I'd hate to have seen what it would have been like last summer if we didn't have El Nino and we had that warm of ocean, because it was unprecedented last summer too. It's just even warmer relatively now.
So my question would be, now that we're transitioning from El Nino to La Nina, would this be the summer that we might see that, Jeff?
Yeah, I mean, it's hard for me to rationalize that we get less than 20 named storms like last year.
Yeah. And
it seems more likely we would probably have somewhere in the range of 25 storms or something like that. Wow. And last year, what we didn't have was very strong. We had some strong storms, but we didn't have an overabundance of strong storms. I would be really surprised if we didn't have more hurricanes this year and stronger hurricanes than we had last year. So first things first, let me show you. Let me show you what it looks like. Let's take a look. You know, we looked at it briefly before. Oof. These are ocean temperature anomalies. So what our ocean temperatures are now relative to what they normally should be over the past 30 years. And remember, the water temperatures the last 30 years, Val, haven't been normal at all. Right. The oceans have been warming. The normal would have been somewhere before we started burning fossil fuels and adding greenhouse gases. Right. So the normal would have been around 1900 or so, late 1800s, early 1900s.
Yeah.
But really, since the 1970s and 80s, the temperatures have gone up a lot. So when we look at these anomalies and we're measuring them relative to the last 30 years, you see lots of oranges and reds. Yeah. Imagine what those colors would be if we were measuring it based upon what the climate was back in the 1950s or before it, around 1900. Right. It would be just really bold reds. Right. To give you an idea, we're just talking about what was normal for the past 30 years. Okay. And by the way, the normal amount of hurricanes, number of hurricanes a couple of years ago was 12. Now we've had to up the average to 14.
Right, yeah.
In a very short period of time. So it shows how things are kind of changing across the Atlantic Basin, Val.
Yes.
So you want to talk about some stuff?
I do. I want to talk about, because you did say that there's a correlation in terms of these temperatures and how active a hurricane season is. Could you explain that to me, or do you have any graphics that will show how that transition has been?
Yeah, why don't I fast forward some of these graphics, and we'll go past some of the other graphics I was going to show you.
We can come back to that.
But I think this is not exactly a correlation map that you see right here.
Okay, it's a comparison.
Let me bring this up full so you can see comparison, between this year's water temperatures this February.
Right.
Compared to 2005 in February 2010, February 2020. The reason why I show 2005, we had 28 storms that year. The reason why I know we had 28 storms is I have it. You see the number on the right?
I see that, yeah.
Okay. That's what that means. And in 2010, we had 19 storms, but it was a very active season because we had a lot of hurricanes and a lot of strong hurricanes. 2020 was the most active season on record. We had 30 named storms.
Yeah.
Um,
And
so
you can see the warmth. So the orange and the reds, basically that it shows how warm these waters are in that many
relative to
development
what it should be.
age.
These are
Right.
called anomalies or
Okay.
departures from
Relative
normal,
to
right?
what they should be, yeah.
And you can see that they don't even hold a candle to 2024 in
No,
February.
I know. That's
Yeah.
that's an astronomical amount of oranges that we're seeing there.
So
Deep orange.
I don't even think I'm going out on a limb by saying if you were to forecast a season with 25 named storms, that
Yeah.
you may actually be being too conservative.
Right.
It's conceivable. Things can happen.
Mm-hmm.
Without a doubt, we could see the water temperature start to warm. A lot of this warmth, not all of it, but a lot of it is near the surface.
Yeah.
So if you get the right type of winds,
Yeah.
stronger winds, it can upwell cooler water from below. We
Okay.
can cool those temperatures in the main development region of the Atlantic. So this is not set in stone. What you see right here is not necessarily what you're going to have by June when hurricane season begins.
How normal is this? I mean, how normal is this? Are we to
question.
see this? Yeah.
Well, I'm going to show you.
Let's
I mean,
see.
it's
Yeah.
actually fairly astronomical. So what you're looking at here is a graph of the water temperatures in every season, January, February, March on the bottom. You can see
Yeah.
it on the bottom axis.
Yes, the months.
And those numbers on the left axis, 19, 20, 21, that's Celsius because
Okay.
meteorologists like to make things complicated. So they do it. And other people in the world,
In our
Americans,
South
like to make things
Americans, we like
complicated.
Celsius.
Yeah, that's right. But anyway, with all that said, the dashed black line you see in the middle of that graph,
Yeah.
that's normal. Normal.
Average.
From 1981 to 2024. So if you can look at the bottom there, you can see 1981. So basically, we start the graph in 1981, and water temperatures were around 18.5 degrees Celsius.
Okay.
Now, look at 2024. It's not even
Yeah.
a part of the spaghetti. It's actually
No.
separate of the spaghetti.
Yeah.
Like it jumped up. And actually,
Yeah.
2023 is the other red line you see right underneath it.
Right.
You can see just how much it jumped up last summer and how warm the. So this is a continuation of the warmth from 2023.
Yeah.
Right now, we're at 20.5 degrees Celsius. So we've seen an increase of around 2 degrees Fahrenheit from normal and around 3 degrees Fahrenheit from the early 1980s.
Yeah.
That's a lot. But this is the look. And one more thing, it might not stick out to you, but do you see the world, kind of like the part of the world right there?
Yeah.
You see that red
On
box?
the right. Yeah.
That's the average of the whole red box. It's a huge area. We're not talking about
Yes.
a 2 or 3 degree temperature change in a small little region. We're talking about a 2 to 3 degree temperature change across that whole big red box, Val.
Yeah, yeah.
So let me
The
just
question that everybody probably is asking: what's causing these temperatures to rise so much?
That's a great question. The base, that gradual increase, that's climate change. That's the majority of it, right? So
Right.
to get from 1981 to what would be 2023 in February,
Yeah.
where it was kind of at the like top end of the spaghetti there,
Yeah.
that's climate change. The question is, when you go from the top end of the spaghetti and jump up to where we are today in the North Atlantic, that's a bigger question, right? That's not climate change. There's something else that's happening there. A part of it was weakened trade winds,
Okay.
which we saw last summer, and it seems to be continuing, probably somewhat due to El Nino in the Pacific
El
Ocean.
Nino. Okay.
Yeah,
So
but it
different
also is a reduction, we think, in aerosols. So,
so less pollution, you mean?
less pollution. Yeah,
So how
and
is less pollution is supposed to be helpful for the environment? How is that causing?
it's true. Now, this is really, really interesting, but you have to bear with me here.
Okay.
So we passed the Clean Air Act back in the 1970s.
Yes, we've
and
talked about
we've
that.
we've gradually taken the pollution out of the atmosphere.
Uh-huh.
During the 1970s, we weren't seeing a lot of greenhouse gas warming. It was being obscured by the pollution. So greenhouse gases were warming the planet up, but the pollution was blocking the sun. So it ended up kind of evening out. Do you know what I mean?
Oh, I see.
So now, as we take the pollution out of the atmosphere,
Yeah.
we are unveiling all that pent up heat that's been there all the time that we couldn't measure.
And now we're
So
letting all that
Now
sun
that the heat's
energy.
been there, it's
Yeah.
just simply that the sun's been blocked a little bit. And also one other thing, Val, this is probably the thing that you're not going to expect and the folks at home are not going to expect. The effect of reducing pollution is less direct than it is indirect. And what I mean by that is, yes, pollution can block some of the sun.
Okay.
But more importantly, pollution acts as what we call condensation nuclei for clouds to form. I know you're about to. Okay. I'm good. I can't go any
We're
further.
gonna go back.
We have it. Can I tell you what a condensation nuclei is? Basically, you can't condense water vapor into liquid water without condensing on some very small, tiny particle like pollution or salt, suspended salt in the atmosphere. So those particles act as essentially the water can adhere to it and form rain droplets, right?
Right.
So less pollution means less chances to form clouds. Less clouds mean more sun gets through, less is reflected to space, and so then you warm up the North Atlantic. So that effect has been happening for the past couple to few decades, right?
Yeah.
I mean, you could say, well, why don't we just start polluting more? Fine, but pollution leads to heart disease, it leads to lung disease, so there are gives and takes.
Right.
The other thing is in 2020, something astonishing happened.
What happened?
The shipping industry, which regulates itself, by the way, the aviation industry also regulates itself when it comes to pollution. The shipping industry decided to take sulfur out of their oil.
Okay.
So they said, okay, ships, you can't use sulfur in your oil anymore.
Okay.
Well, that has caused a tremendous drop in pollution in just 2 or 3 years across the North Atlantic, especially across the shipping lanes and especially across
developing
the Atlantic.
area.
Well, north of the main development region.
Okay.
But still, the pollution, it doesn't have gates, right? It doesn't have fences. So, so it
filters
affects
in.
more than just the shipping routes, which are mainly across the North Atlantic. So there's been a drop in pollution. So we think at least some of the increase there, that spike in 2024, that is due
since then
to that as well. So a reduction in pollution, a reduction in trade winds, not allowing water to upwell, kind of. There was a big area of high stable atmospheric high pressure across that basin too last summer. But what's going on right now? It's still happening in February. I think we're kind of scratching our heads saying, what is going on? Why aren't we seeing the heat reduce? I think there's a chance we might see it reduce a little bit as El Nino dies, and it is dying now very quickly across the Pacific. So we'll see in the next 2 to 3 or 4 months or so if we can start reducing that heat in the Atlantic. One more thing I want to show you, Val, before I move on. This is another way of looking at how anomalous, how odd, how unusual, how uncharted, territory we're in right now. This shows something called I'm going to get buzzed on this. I know I am. It's something called the standard deviation.
I'm buzzing you.
So instead of talking about it in terms of standard deviations, which by the way, we're at 4.5. Anybody who knows standard deviations out there, and there's at least some people watching that know what we're talking about. Forget about 4.5 sigma or 4.5 standard deviation. What it means is right now, the chance of any day in February being as warm as it is relative to what we consider normal over the past 30 years, the chance is only 1 in 280,000.
What?
1 in 280,000 chance. So it's almost like winning the lottery.
Right, yeah.
And if you compared this, and let me go back to just us. Actually, let me go back to this graph in us.
Yeah.
If you compared this to a climate not of 1990 to 2020, right? Because we're comparing to what is recently normal. If you can compare it to what's a natural climate before humans started warming the atmosphere, well, that would go up to a 1 in a trillion chance or something like that. Like it would be so absurdly ridiculous that it's not worth mentioning. The point is it's incalculable. It's not possible for it to be as warm in this February in a natural, normal climate. And that's the point that we try to get across to viewers to give it. Yeah, go ahead.
Are we going to see this more often? Is this something that's going to become a normal thing?
Well, you can see that, but this whole time we've been since last January, we've been at least 2 standard deviations to 4 standard deviations above normal. That's the chances of that are at least in the tens of thousands, and now we're in the hundreds of thousands.
Yeah. So we have to hope that that we're going to be able to bring that down. That's
right, and it's not going to happen anytime soon. If anything, over the next 30 years, we are going to continue warming. We'll see what happens after 30 years, and that's really all in our hands, right? We control our destiny when it comes to how much greenhouse gases we want to release into the atmosphere and how much more warming we want to see occur. Sometimes the lesson is learned to some degree when you have really bad hurricane seasons. I hope it doesn't come to fruition this year, but with all this extra energy, kind of like high-octane fuel steroids in the oceans, we may see some stuff happen that we rarely, if ever, see, and that may kind of wake people up,
No, I hear you on that. I'm trying to go through some of these messages, some of the questions that we're getting.
No curses. You can't read anything.
I'm not going to read the ones
I know
that
there are at least some that probably are cursing, but we're going to have to avoid those. While you're doing that, because I know people love graphs. They just love. I mean, who doesn't love a great graph? Do you really?
Well, yes, because they illustrate the point.
Okay,
They make it, yeah.
I'm going to bring this up then. So this is the departure from normal temperature-wise in the North Atlantic Ocean. So that's anywhere from the equator up to almost Greenland. And you can see that it really started warming around 1995. Before that, the pollution was obscuring the greenhouse warming. But the greenhouse warming has been happening since 1900, and it's really accelerated since 1980. But you don't really see it in the North Atlantic Ocean until we reduce that pollution, right? That starts happening in the 80s after the Clean Air Act is enacted and it starts to take hold. And you could see those water temperatures really start to shoot up recently. But look at what happened from 2023 to 2024. Look at that jump.
Yeah.
That's
It's a big jump.
that's the alarming,
Yes.
that's the alarming jump that we
Yeah.
see here. That big jump just over the past year.
Yeah, it's drastic.
Yeah.
It really is. I do have a question I want to read. It says, Jeff, on subject temperature, they have satellite and buoys that read water temperature. Which is more accurate?
Well, the buoys are more accurate, but buoys don't exist everywhere. Although we have a much bigger network of buoys than we ever have had.
By the way, before you continue,
there are thousands of them now, but it used to be there weren't that many at all.
I just wanted to mention the name of the person that submitted the question. This is David Faisal.
Yeah,
So
that's a great question. I mean, ultimately speaking, you always want to have an actual instrument that can measure. Satellites do a great job where you don't have actual observational data. We now have a lot more of these buoys that are floating all around the ocean. Tremendous amount, thousands. If I have time while you're doing your thing, I can look up to see exactly how many have. But it's many thousands. It's probably not tens of thousands, but so it's a lot more than there used to be, which gives us a lot more accuracy.
Yeah.
We had showed this graphic of the main development region, but we didn't really elaborate on it much, did we? Well, we did a little. I think we may have enough. Yeah.
Can you put it back up so
Well,
that
yeah,
we can
there it
take
is.
a look?
I think this is what people need to see because this, most of the other graphics are talking about the whole Atlantic, which is crazy.
Yeah.
But the main development region is what we're more concerned about because
Hurricanes.
we're worried about hurricanes. That's
Yeah.
right.
And because I don't know if you mentioned it, but obviously warm water acts like fuel for these storms when they're developing.
Yeah,
they can get
that's right.
stronger, they can get bigger, right?
Yeah, for every degree Fahrenheit of warming, and I always mess up the exact amount, but it's something like it can be as much as 10% stronger a hurricane.
Yeah.
Theoretically, if all the other conditions are perfect.
Yeah.
So it's not out of the question that you could take a storm that has winds of 150 miles an hour, and if your water temperatures are 2 or 3 degrees Fahrenheit warmer, and they have been, that you could see a storm that has winds of 170, 180 miles an hour rather than 150 miles an hour. And in terms of its ability to produce damage, it's an exponential increase in damage that it causes. In fact, I did a story because we were doing that Category 6.
Yeah.
If you remember...
Last episode.
That's right. If you remember, if you had winds of 160 miles an hour, it's a low-end Cat 5. In the Bay Area, there was a scenario that caused about $250 billion worth of damage, which, by the way, is a lot more than Ian. Ian caused about $110 billion. In the Tampa Bay area, is more people, more structures, probably more value, and
Right.
And also the storm would hit the bay and it would cause more storm surge.
Right.
Anyway, the estimate was $250 billion for a wind of 160 miles an hour, but the estimate for a storm with winds of 190 miles an hour, which would be, if we ever came up with a Cat 6, it would be a low-end Cat 6. That would be somewhere near $1 trillion worth of damage. So it's quadruple the damage. So it's not, when you talk about an increase in wind speed in hurricanes of like 20 or 30 miles an hour, you're not talking about just a small increase in damage.
Yeah.
You're talking about huge increase in damage.
Yeah, absolutely. So I do want to ask a question in regards to, we knew that some of the positive traits of having El Nino around was going to be that we were going to get more wind shear coming our way, especially in hurricane season, that helps break up apart some of these storms trying to develop. Is there any positive traits that we can expect from La Nina?
Not for the summer. Not for the summer.
Jeff, I don't like the way that sounds.
Well, because La Nina can actually, if you look at the stats up until 2016, I have to go back and redo the stats. But if you look at the stats up until 2016, you find out that La Ninas tend to have about almost double the amount of hurricanes that El Ninos have.
So let me get this straight. We have warmer waters, and we are headed towards La Nina.
That's right. That's right.
So if we were to answer that question, what does that mean for hurricane season?
Well, I'm going to put it up there. So right now, the Eastern and Central Pacific there, where you see the blue,
Yeah.
well, it's really warm right now, but this is
Yeah.
actually the forecast for the summer. So
Okay.
you can see a complete, like flipping a switch. We go from
Yeah.
a lot of red
Right.
to a lot of blue in the El Nino region. Now, and it's actually called the La Nina. When water temperatures drop below around 0.5 degrees Celsius below normal,
Then
that's called La Nina. And by the
okay.
way, I should just make clear to everyone that La Nina and El Nino is a natural cycle. It has very little to do with climate change. If climate change didn't exist, El Nino and La Nina still would happen every couple of years, every couple to few years. El Nino and La Nina are having an impact on climate change is having an impact on El Nino and La Nina. There's a lot of research into that, and we're not exactly sure what that's going to mean in the future. We have some ideas, but the research is not set in stone by any means. But what you see right there, that blue in the equatorial Pacific Ocean, that is the forecast from one of our computers, but almost all agree we are going to see a mature La Nina just in time for the peak of hurricane season.
Okay.
This is for July, August, September. These are water temperatures. So below normal in the Pacific, but look at the Atlantic,
Yeah.
well above normal
Right.
across the Atlantic.
Yeah.
So this is a double whammy here
Yeah.
when you have cold Pacific, because the cold Pacific, what that does is it reduces the wind shear across the Atlantic. Because,
Right. Which is
the climate the weather doesn't stay in fences, right? So if you change something across the Pacific,
Yeah.
eventually it has ramifications on the Atlantic Ocean.
Yeah.
Reduced wind shear, hot water temperatures, a recipe for a very active, if not hyperactive hurricane season.
Yeah. And just taking a step back, what you were saying about how climate change is affecting, for instance, perhaps a stronger El Nino that we haven't seen in previous years. That would mean stronger or more active jet streams, correct? And that has a different...
During El Nino, you're right. El Nino does cause an active subtropical jet. And actually, it's some of the folks that are watching right now may have heard of that flight that traveled across the Atlantic at 835 miles an hour. If it weren't for El Nino, it's unlikely that the jet stream would have been as strong as it was.
I would love to do a climate classroom on that.
We are next week.
Okay, great.
But,
I'm so excited. I said
winking,
it on purpose.
You can't wink at me. You can't wink at me and not be seen by all the viewers. She's winking at me like we're keeping it a secret. Thank you for setting up the tease for next week.
So if
Now,
you
you're
guys,
very smart.
you want to stay tuned for next week's episode because it's going to be a really exciting one.
We're
a very
talking to a
interesting one.
scientist who researches upper level winds and how a warmer climate is impacting not only stronger winds in the upper atmosphere, but also turbulence,
Right.
which people hate.
I
hate it too.
hate turbulence.
Let me show
I
you
don't
one
like
other graph here, Val. So that is a look at water temperatures.
Yeah.
Now we're going to look at precipitation anomalies. Precipitation anomalies are
Rain.
departure from average rainfall.
Okay.
Why would we look at that? We look at it because wherever we see greater than normal rainfall in the tropics, we know is probably going to be the storm track.
Yeah.
If it's really green, then that means that's above normal rainfall, and that means we're going to see probably an active hurricane season, or at least a lot of disturbances moving over a certain area.
Right.
So let's show you that. Okay.
Look at that.
That's the forecast for
it's
July,
looking
August,
spicy.
September. I'll bring it up full so
Yeah.
people can see it at home. And yet spicy
lot of rain,
is the
yeah.
word. I mean, because you can see that the precipitation departure from normal in the shades of green, well, we don't see any
Florida's in
blues,
it.
but we
Yeah.
see lots of greens. And so you can clearly see that it is the main storm track
Right.
where the model is picking up the greatest increase in precipitation. So you know for sure there's going to be more disturbances, and you
those
assume because there's going to be low wind shear and because water temperatures are going to be really warm, that these will turn into, a lot of them will turn into tropical storms and hurricanes. And they're heading straight for the Caribbean. The Caribbean is above normal rainfall too.
Yeah.
And where do they go? They go either Florida, Cuba, the Yucatan, or maybe the western part of the Gulf of Mexico. That's according to this one model.
Yeah.
But I've seen many models, and they all point to pretty much the same thing. We have the ability now, and we should marvel at this, right? Think about this.
Yeah.
We cannot, people take for granted weather forecasts now,
Yeah.
right? Oh, you can tell me what it's going to be a week from now. It was a miracle 30, 40 years ago that we could tell you what the future was going to be,
Yeah.
right? Now we're able to peer into the summer. We can't tell
Right.
you a hurricane's going to form on July 14th and it's going to
Right.
hit, San
Exact
Juan.
time, yeah.
But we can tell you, yeah, our computers pretty much all agree it's going to be a La Nina, and we're going to have an active hurricane season.
It's pretty amazing. It really is. Yeah. Technology and the advancements that we've seen. I mean, but at the same time, it's scary because this is what we have to look forward to.
At least we have time to prepare.
Oh, that's a good one. There you go.
Have time to prepare.
We do. Yeah, that's the smartest way to go about it.
I wouldn't say I'm scared over it, but the truth really is, Val, I'm gonna bring you in for this, okay? I'm gonna bring you in a little bit closer because we have a serious point to make here.
Yeah.
It's becoming really difficult as a meteorologist and a climate scientist to ignore the fact that we have had nothing but active hurricane seasons lately.
Mm-hmm.
And that water temperatures in the Atlantic, they just refuse to go down.
Mm-hmm.
And I think there's a general idea in the meteorology community that we just are not going to see inactive hurricane seasons anymore. That this increase from the average of 12 named storms a few years ago, to now already 14 named storms because of the active seasons we've seen over the past couple of decades, especially the past 10 years, that is not likely to abate. Yeah. That is not going away. I don't know if we're ever going to see an inactive season again. If last summer's El Nino wasn't strong enough to overwhelm the Atlantic Ocean, and it failed. Yeah. I mean, it helped.
Yeah, it helped.
It helped, but it failed.
Yeah.
Then I don't see what is going to come up in the future on a consistent basis that's going to help us. Now, of course, there's going to be climate patterns on a given year or two where there's a lot of dry air, something weird's going on. So yeah, there'll be the occasional year where maybe we see normal activity. Maybe we get lucky once and activity is a smidgen below normal, but I don't see that there's going to be many of those. I think ultimately we just have to this is the new norm.
Oof.
And the new norm could keep changing because as long as water temperatures continue to increase, and they will at least for the next 30 years, the new normal is going to be a new normal every couple of years. It's a new abnormal. It just keeps changing.
The new abnormal. Yeah. Well, time will tell. We'll just have to stay prepared. I know that we are protected here in the Tampa Bay area, though, so we have nothing to worry about.
Well, I don't know where you got that from.
No, I don't. From a study, study that you did, right?
Study.
That it said that we weren't going to get hit.
Well, okay. Let me clarify for everyone. The study didn't say we weren't going to get hit. It just says that we get hit less often.
Less often.
Yes, less often than Miami and New Orleans, which we already know. But the study said that's normal. The study that we did with Columbia University this summer, which was great, right? How often do you hear about a TV station doing their own hurricane
that was
study?
amazing, yeah.
What I was looking into when we did that study with Columbia was, have we just been lucky for the past 100, 150 years? Or is this just the normal pattern around here? And we ran the numbers, and it turns out the computer model said, yeah, this is normal. You just don't see that many hurricanes there. We know why. We've always known why we see less.
Yeah.
But we were just curious if maybe we've just gotten extra lucky over the past few decades.
Yeah. Mostly it has to do also with the geographical location. Is that right?
Yeah. Yeah, storms tend to go that way, and they don't oftentimes curve back. And so it's a little harder to get here. Yeah.
It only takes one, and that's why we need to be diligent.
Any questions from our viewers? Anything else you want to ask?
No, I think that you answered all my questions, and now I know what we have to look forward to. So, yeah, we're going to stay prepared for the summer.
All right. I'm going to bring up the graphic one more time and show you what the Atlantic Ocean looks like. Oh, and by the way, you know what? Let me bring it up and show you also what it looks like in the Pacific. Okay. So we still have the warm water temperatures in the central and eastern tropical Pacific. That's the El Nino. That is going to turn blue starting in a couple of months. We'll start to lose El Nino completely by May. Yeah. And then by around July or August, we should already be near or in La Nina. But that's a look at the Pacific currently, and this as a look at the Atlantic currently. So everything is warm.
Oh, wow. It definitely looks worse.
All right, let me bring you back in. And I want to thank you for, as always, for making this an interesting show.
Thank you, Jeff.
You always have great questions.
I appreciate it. Thank you for having me.
Yeah, and I want to thank everybody at home for listening to the show. You can actually read more about this particular story, and I encourage you to do so because I kind of break down the science for you. Ocean temperatures are in uncharted territory. We're going to talk about what that means for hurricane season. Go to WFLA.com. You should see it on our homepage. If you're listening to this days in the future, then click on the weather tab, then click on the climate classroom tab, and it should be one of the lead stories there. And before I leave you, just let me tell you, you can listen to this not only where you're listening to it now, which would be either Facebook or the WFLA.com website, We're going to package this up. We're going to send it to YouTube, so it'll be available on YouTube. And we're also going to send it to podcast land. That would be Spotify and Apple Podcasts. Again, thank you very much for joining me. I'll see you again here next week. And next week, we are talking about, Val, what are we talking about?
We were talking about the active jet stream.
The really strong jet stream and those crazy record-setting flights across the Atlantic Ocean and what is behind that. Again, I want to thank you for joining me, and I will see you next week on Climate Classroom.
Watch or listen to Jeff's Climate Classroom, powered by ArmorView Window and Door on WFLA social media platforms, and find Jeff's climate reports on WFLA.com.